do I dare try to do parenthood? Let's see. Okay, so I'm making a buzzer. A buzzer is going to be just like a counter, except that whenever it would have said something that's a multiple of 7, it says buzz instead. So I'm going to say let parent make count. Okay? The make buzzer was in parentheses. So that means there's no class variables in the buzzer class. We just went right to the let that's for the instance variables. So parent is an instance variable. And now what the object looks like is lambda message EQ message. Tell you what, we'll make that be true only for the local count, not for the global count. If message is local, then here's my method, lambda of nothing. I don't know why it's doing this highlighting. That's weird. So let result be open, open, parent, quote, local, close, 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 close. Yep. Now I'm going to say if equals 0, remainder result 7, oops, why is it indented to there? That's not right. Okay, what did I do wrong? This is the trouble with doing things on the fly. No, it is right. It's just the blinking that's wrong. Then I say, whoops. Then I say, quote, buzz. Otherwise, I say result. So that's the end of my lambda. That's the end of my let. That's the end of my lambda. That's the end of my con clause. And everything else we're going to let the parent handle. So I'm going to say else parent message. Close the lambda, close the let, close the define. Yeah. Yeah. Uh-oh. Right. Oh, whoops. One more parenthesis. Okay. Not there? After result. Really? Oh, look at that. Right, you are. Okay, so here's B. It's a buzzer. I'm going to say B, quote, local. 1. Oops. Wait. There we go. 2, 3, 4, 5, 6, buzz, 8. Okay? Now, the quote global 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. Okay? So this is inheritance. And the key point, I think, what did you? Oh, it didn't help. Didn't help either. Oh well. The key point is this else clause that you can't see because the way this stupid terminal thing works. If the message is not one that I'm specializing in the child, then the child's dispatch procedure just calls the parent's dispatch procedure. This gets back to what's the good of having two levels. We can have lots of different messages. Imagine that the object that's my parent has 40 different messages, each that takes a different number of arguments. I don't have to worry about any of that. I can just say, if this message is not one that I've specialized in the child, then just pass the message to the parent. The parent dispatch procedure will return a method, and then whoever called me will call the parent's method, never knowing that it's the parent's method instead of the child's method. Okay, so this is another advantage of treating methods as data, having a dispatch procedure that returns a method, because it lets us do things like this else clause very easily. Questions? Yeah. What would the else clause look like with multiple parents? Okay, so there would be clauses in the cond that would say parent 1 message, and parent 1 would return true or false. If it returns true, then I return true, meaning anything other than false, right? So it returns a method or false. If it returns a method, then that's what I return. Otherwise, we go to the next cond clause, which says parent 2 message. And that returns a method or false. And then when I run out of parents, then I return false, else false. Okay? Yeah, it really is very cool how you can implement hugely complicated object structures with not very much real scheme code, actual non-OOP language scheme code. And what makes it work is a combination of two things. One of them is lambda, so that I can represent my object as a procedure, as a dispatch procedure. And that's very, very convenient. And the other is lexical scope, which means, remember, that dispatch procedure, here's C1, which is C1's dispatch procedure. It remembers where it was created. And because of that, it remembers its object variables. And I don't need a special OOP language to make that be the case. Okay, we can do it in plain old scheme.